Welcome to today's video. Today's video is for Advanced Geometry, Chapter 7, Section 4, Similarity in Right Triangles. So this is about geometric mean specifically. So we're going to be looking at altitudes drawn to the hypotenuse of a right triangle, and that forms the geometric mean. So like I mentioned in class, everything that we've been calling mean that we normally think of as the average is really the arithmetic mean, and we are going to learn geometric mean today. And then we're also going to learn harmonic mean. So there are several different types of means. So the first thing we have is a theorem, and it says the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original and to each other. So I like to call this one the geometric mean theorem. I'm going to use this one in proof so the name isn't as important. And this is the definition of geometric mean. For any two positive numbers, a and b, the geometric mean is a positive number x such that a over x equals x over b. Okay. Now, one thing that I like to do is I really don't like to work with it in this proportion form. So what I like to do is I like to cross multiply it. So you get x times x squared equals a times b. And then even more, if I take the square root of both sides, and geometric mean is only positive numbers, so I don't have to worry about doing plus or minus. If I take the square root of both sides, I get the square root of AB. A lot of times I like to use it in this form, and this is the form I'll use. If you want to go back and do the proportion and then cross multiply and then solve for it, that's fine. The reason why I like to use it in this form is because this form helps me remember it. Because I always think about arithmetic mean is if I found the arithmetic mean between two numbers, I would add them together and divide by 2. If I want to find the geometric mean, it's kind of like a step up. Instead of adding, you multiply, and instead of dividing by 2, you square root it. Okay, so for me, it just kind of makes a tie between the two, and I think this is a whole lot easier to remember. So if I want to do the geometric mean between 4 and 18, what I do is it is the product of them square rooted. So 4 times 18. Now, if I want to do the square root of 4 times 18, instead of multiplying them together and then square rooting that, what you can do is you can square root the parts. So square root of 4 is 2, so this is 2 root 18. And then 18 has a 9 in it, so I can break this up into the square root of 9 and the square root of 2. Square root of 9 is 3, and then the 3 times the 2 is 6. So this is 6 root 2. So the geometric mean of 4 and 18 is 6 root 2. And again, if you want to set up this proportion, what you would do is you put the variable, the geometric mean, on one diagonal, and you'd put the other two numbers on the other diagonal, and then you would cross multiply and solve. And you're welcome to go back to that if you would like. Okay. Now, we have a corollary to this that says the length of an altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So what this one is saying, if you look at the picture below, I'll use it, is it's saying if you take the length of the altitude, so that's going to be CD, it's the geometric mean of the two parts of the hypotenuse that it separates. So it would be the geometric mean of AD and DB. Okay, there are going to be 3 of these. This is the first one. So the altitude is the geometric mean between AD and DB. And this is a proof, so we'll do this one in class. I'll prove that it's true. But basically, once you use geometric mean to prove that triangles are congruent, then it's just going to be a proportion of the sides. Here's another corollary. This one says the altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent side to the segment to the length of the whole hypotenuse. So what it's saying is if I take one of the legs, it's also a geometric mean. So AC is a geometric mean, except for this time it's a geometric mean of the piece that's closest to it, AD, and then the whole entire hypotenuse, which is AB. And because there's 2 legs, it actually doesn't matter which way I do this. I can also do CB. CB is another geometric mean, so CB, and it's the geometric mean of this part that's closest to it, DB, and the whole thing again. So what we have is we actually have three geometric means. The altitude is the geometric mean of the two pieces of the hypotenuse, and each leg is a geometric mean of the piece that's closest to it on the hypotenuse and the whole thing. And this is another one we can prove. So if I have a picture down here and I want to solve for x and y, first one, I think y is the easiest to solve for, but it doesn't matter. For this one, y is the geometric mean of the two pieces. So 4 times 5, so it's equal to the square root of 20. There's a 4 in there, so square root of 4 and square root of 5. So this is 2 root 5. And x is a leg, so it's the geometric mean of the piece that's closest to it, and then the whole thing, which means we have to add these together. So it's 4 times 9, which is 36, so x equals 6. So last example, a 300-meter path to the information center and a 400-meter path to the canoe rental dock meet at a right angle at the parking lot. So we've got a right angle at the parking lot. And Marla walks straight from the parking lot to the lake as shown, where the sign tells her she has 320 meters from the dock. So this is 320, and we want to find the other part. You can do this two ways. We don't have the altitude, so we probably don't want to do anything to find it. We could, and we can do the Pythagorean theorem on the right-hand side, and we could find it. But we're given one of the legs. So I can either use the 300 to do this, or I can use the 400. I don't recommend you use the 300 because then what you're going to have to do is you're going to have x, and you're also going to have x plus 320, which means you're going to have the variable twice. You're going to end up getting a quadratic that you're going to have to solve. If I use the 400, then it's a geometric mean of the 320 and the 320 plus x, and then I just have the variable once, and I'm going to end up getting something that's linear that's a whole lot nicer to work with. So I can say that 400 equals the geometric mean of the 320 times the 320 plus x. So first thing I'm going to do is square both sides. So this is going to be 16, and this is going to be 320, and then 320 plus x. And now I need to distribute. So let me do 320 times 320. And that's 102,400. Don't forget to distribute to the x, so that'll be 320x. And then if I take the 160,000 minus the 102,400, I get 57,600. And now I just have to divide by the 320. And x equals 180. So my distance here is 180 meters. Done. Okay. So that's it for today's video. I am going to talk about harmonic mean. If I forget, remind me in class, and I'll show you the formula for harmonic mean. Thank you for watching today's video. Have a great day.